All right, this is the Algebra 1 new Unit 6, Lesson 6 video. This lesson deals with linear inequalities. And if you remember, linear equations when we talk about that, we're really just talking about functions that have either this basic structure, or we also talked about the standard form. But the key here is that they have an x and a y variable in them. So these are equations made up of two variables. And so examples of these would be like, and the graphs of these functions take the form of a straight line. And so when we say linear, we're talking about things that are lines. So linear. So that should be familiar to you. So for instance, we with the slope-intercept form, which is this form, we learned that in this we have, we call the slope and the y-intercept. And we use those values to graph the line. And the line we graphed on the coordinate plane. And so a linear inequality is basically the same idea, except when we do them, instead of having an equal sign, we're going to have an inequality symbol. So we'll have either less than or greater than, or less than or equal to, greater than or equal to. We'll have one of these for inequality symbols. And let's look really briefly at what this looks like when we actually graph them. So for example, if I had the function, let's do y equals 3x plus 2. So this red line here would be the graph of y equals 3x plus 2. So this is a linear equation. And all of this line and all the points along this line represent points that when I take them and put them into this equation, the x and the y value from all of these different points, they make this equation true. So that's where we get the graph of the line. Well, an inequality says, well, what if I just want the points that are greater than that line? And you can see the difference. So notice there is no actual difference in terms of the actual line that's graphed, but so the border line of this graph is not going to change, but there has now been introduced some shading into this line. And so you can see that this includes all the shaded area, or I could do less than and equal to. Now we have a solid line and we have shading down here. So I kind of want to just real quickly talk about the different ways that the graph of these equations can look. We can have less than, or we can have greater than. And notice in both of those cases, there's a dashed line. And the shading is either below the line for less than or above the line for greater than. Now, if I do less than and equal to, and you see the symbol there has a line underneath the inequality symbol, now I have a solid line. And same thing is true for greater than or equal to. I have a solid line and the shaded region. So anything in the shaded region or on the line itself would be a solution, whereas that's not true when it's a dashed line. So when it's a dashed line, numbers that appear on the line are not considered part of the solution. And that's kind of the first thing they're going to have you do in this lesson. So the first thing they're going to have you do is they're going to give you a piece of information like we see here. They're going to give us a point, and they're going to give us a linear inequality. So just like what's in the box there, you're going to receive that information. And then they're asking whether or not that point is a solution. Now, we could graph this linear inequality and then look and see if this point 1, 2, 1, 2 is a solution. In other words, is it in the shaded area? But we're going to practice doing this first by just doing it mathematically. So I'm going to take this equation 4, and wherever the x is, I'm going to put a 1. And then wherever the wherever the y is, I'm going to put a 2. Four times 1 is 4. Minus 7 times 2 is 14. 4 minus 14 is negative 10. And so the question just becomes, is negative 10 greater than 10? Is this true? If it's true, then you say, yes, it is a solution. If it's not true, if negative 10 is not greater than 10, which it isn't, then we are going to say not a solution, or just in this case, no will be our answer. So that's what you're going to do for your first set of problems. I'm going to scroll down here and show you. You're going to be given a linear inequality, and you're going to be given an xy point. So you need to take 2 and negative 2 and put them in for the values for x and y. So x is going to go in right here, y is going to go in right here, and then you're going to work it out. At the end, if the statement that you get is a true statement, then you're going to put yes. If it's a false statement, you're going to put no. And that's what you're doing for number 2, 3, and 4, and 5. You are just simply taking that point, plugging in the x and the y into the equation, and deciding whether or not the statement you get is true. Then the rest of this is just graphing. So we're going to just kind of look at these together. I want to just remind you of what the different numbers here mean. So I'm going to jump back over to our example here. Remember that, like I said here, the slope and y-intercept of the graph are the m and the b. Okay, so these are the m and the b as well in the inequality, so that still holds. So those values there tell me how the graph looks. Remember that the slope of a line is also known as the rise over run, and it tells me how much the graph goes up and over. So if the graph's like this, then the slope is telling me what's the difference between how much it goes up and how much it goes over in a numerical form. So if this goes over 3 and up 4, then my slope here would be up 4 over 3 or 4 over 3. That would be the slope of this line, and it's represented with the letter m. All right, and then the y-intercept is our other value. The y-intercept is a value that tells us where the line crosses the y-axis. So if, again, the y-intercept tells me that on my graph, let's say I have this as my graph, and the line comes in and it crosses right there. That tells me right there that I have a y-intercept. Oops, let me erase that real quick. Tells me that I have a y-intercept equals 2, because it's the y value of 2. So the y-intercept would be b equals 2 for this line right there. So with that information, hopefully you remember a lot of that. Shouldn't be too hard to remember. We're going to be looking at these different graphs. The other piece of information we need is really just to remember where the shading is. So you basically need to remember that when we're looking at these, and I'll make sure to post a kind of summary of this in the notes. If you have a solid line versus a dashed line, solid lines look like this or like this. Dashed lines look like this or like this when it comes to the actual symbol. And then ones that look like this first column are going to shade below the line. And the ones over here are going to shade above the line. Again, armed with that information, we come over here. We see here we have a line where we know that it's being shaded below the line, and it's solid. So we know already that we're looking for the following symbol: solid and below. So this I can get just by looking at the picture. And then I scroll down and I see at my answer choices, only one of these answer choices, two of these answer choices have the correct symbol. Only these two have the correct symbol, so these are no good. And then it's just a matter of, is this slope number here x plus 9 or negative x plus 9? In other words, is it a positive or negative slope? Well, we know that positive slopes go like this, basically, and negative slopes go like this, basically, positive, negative. So we clearly have a negative slope in my graph above. So then I'm going to choose this as my answer choice. And that's the kind of things you have to do to solve these problems. So I'm going to let you do number 7 on your own. Remember that the slope number is representative of the rise over run. So the rise is how much it goes up or down. The run is how many spaces it goes over. So you need to find some points on the graph, and you need to figure out how many it goes from one point to the next. And again, just to get you started, there are clearly points here, 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 and so on. I'll let you do the rest of that yourself. And then don't forget what the y-intercept is as well, and match with the correct graph. More of the same in number 8. I'll let you do that one as well. They just want to know which of these two graphs represents the thing that they're describing here. Okay? And then lastly, it says Paul wants to order flowers for Mother's Day, and can choose any number of roses and lilies for his mother's flower arrangement. He has a maximum of $50 to spend. Each stem of lilies costs $3 and roses cost $3.50 each. Which inequality represents the situation? All right, just to get you started. X is lilies. This is the cost of lilies. Y is roses. This is the cost of roses. So that's the first thing you need to look for in the equation to make sure those are together. And then it says that it is a maximum of $50. So the question is it less than 50? Less than or equal to 50? Is it greater than 50? Or is it greater than or equal to 50? And so you have to decide which of the symbols most matches the description in this question. All right, that's it for lesson 6. Let me know if you have any questions.